All right, friends, we are going to do work on some fractions right now. 3NF. 1 is the standard. The directions say write a fraction for each fraction model. So the first thing we need to do is find the total number of pieces. That's how we're going to determine our denominator, which is the bottom number, which goes right here. That's the number of pieces. That determines what size the piece is. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pieces in our whole. And now we want to see how many pieces are shaded. What number of pieces, how many eighths are represented in this whole. So I count 1, 2, 3, 4, 5, 6, 7. So 7 eighths. 7 eighths. Clean that up a little bit. I'll do one more for you. Then you're going to practice on your own. I'm going to move here to this one. See how many total pieces there are to determine. That tells us the size of the piece. So 1, 2, 3, 4, 5, 6. So I know that this whole is partitioned into sixths. So how many sixths do we have? Well, 1, 2, 3, 4. 4 sixths. 4 sixths, because this is 1/6, this is 1/6, this is 1/6, 1/6, 1/6, and 1/6, okay? So how many of those 6 are shaded? Well, this one, this one, this one, and this one. So 4 6 are shaded. You all are going to practice the rest of these on your own and then come show us and we'll help you out. Fractions on a number line. So I'm looking at fractions on a number line. The directions say represent each fraction on a number line. First thing that I need to do is partition. The number line's partitioned, but I need to label it. Okay, so I'm looking here at my endpoints. I've got 0 and 1, and I want to represent 3/4 on the number line. So I need to partition it. So I know if I need fourths, this is going to be 0/4. This is going to be 1/4. Let me zoom in here a little bit for us. Yeah, 0/4, 1/4, 2/4, which we know is the same as 1/2, 3/4, and 4/4, or 1 whole, Okay, so I need to find 3/4. So now all I have to do is just scan and see that 3/4 is right here. So I'm going to put a little star right here because 3/4 is right there. Let me do another one. This next one, it says mark 3/6 on your number line. 3/6. I'm going to note my 1 and my 0, my ends. I'm going to label my 6th because I want 6th, 0/6, 1/6, 2/6, 3/6, which is equivalent to 1/2 because we can see it splits the number line right in the middle. 4/6, 5/6, 1 whole, or 6/6. So now all I have to do is see where 3/6 fits on my number line. So I'm going to scan 0/6, no, 1/6, no, 2/6, no, 3/6, yes. I'm going to put a star there, highlight it. Yay, that's happy. We like that. So that's how you all do that. It is imperative that you label your problems, okay? So the next one, you're going to find 3/8 on the number line. So you need to label the number line with eighths, starting at 0/8 up to 8/8 or 1 whole, and then find 3/8. Next one, you want to do the same thing for 1/4, 1/6, and then finally 7/8 at the end. Next, we're going to work on equivalent fractions, okay? It says use fraction bars to find equivalent fractions. So the first one says we want to find an equivalent fraction for 1/3. 1/3 right here. I can see that this shaded in part is 1/3 because I see this is 1/3, this is 1/3, and this is 1/3. Now I'm going to look at the fraction bars that are listed underneath of it. I know that an equivalent fraction is a fraction that looks different. The numbers might look different, but the amounts that it represents or the value of it is the same. The same amount of space is taken up. So these fraction bars are cool because all I need to see is like I need to draw a line and I'm like I need these. Let's count. Let's see what we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are ninths. These are ninths. So I know that this is going to be 1/9, 1/9, 1/9, on and on till I get 9/9. And I want to know how many of those ninths put together are the same size as 1/3. Well, it's pretty easy to see there. If I color in these 3 ninths, it takes up the same amount of space as 1/3. So what I'm seeing is that 1/3 is equivalent to 3 ninths. There are 3 ninths right there. So 1/3 is equivalent to 3 ninths. You all can work on the next two on your own. This should be a pretty good review since we've just finished fractions. Let me know if you have any questions. Make sure that the equivalent fractions take up the same amount of space. Whole numbers as fractions. The directions say to use the fraction models to write each fraction as a whole number. So what this means, when we're looking for whole numbers, we've got to see how many whole pieces are represented, okay? Whole pieces. Not parts, not fractions, not parts of a whole. We want to know how many whole pieces there are. So I'm outlining to help you out your whole pieces here. So on this top one, it says 5/5. So this is 1/5, 1/5, 1/5, 1/5. 5/5 is equivalent to how many wholes? Well, I just see one whole rectangle here because I know that 5/5, when the numerator and the denominator are the same, I know that that's equal to 1. Okay, I'm going to do this next one for you, so it's a different type of example, so you can see that it's different than the first one. So I see that there's a 2 in the denominator, so I know that my whole pieces are partitioned into halves. So I know that this, we're going to label 1/2, 1/2, 1/2, 1/2, 1/2, and 1/2. Now, I want to see how many halves do I have? How many 1/2 size pieces do I have? So let's just count them. I have 1/2, 2, 3, 4, 5, 6. So I have 6 1/2 pieces, which is they tell me here. How many holes is that? So I can see, well, here's one whole circle, here's another whole circle, here's the third whole circle. So 6 halves is equivalent to 3 whole. I want you all to practice the next two on your own, and then you can move on to the next page and we'll check your work. This one is comparing fractions. So we're going to use the less than, greater than, or equal to signs to compare. So when we're comparing fractions, we have to do two things. We have to see if the denominators are the same or if they are different. Okay? We need to determine if the denominators are the same or are they different. If they are the same, we've got to think about our pictures here. Looking at number 1, they are the same. I have 1/3, 1/3, if I'm looking at this one, and 2/3. So I'm going to draw a picture here, okay? I'm going to draw a picture. I'm going to draw fraction bar. I'm going to partition it into thirds. I'm going to draw another one. Partition it into thirds. Make sure if you're doing this, you draw your rectangles that this to be the same size, or know that they need to be the same size. So here I'm going to shade in 1/3, and below it I'm going to shade in 2/3. Okay? Because I know that these are all 1/3 size pieces. But I need to know which one has the greater value, which one's bigger. So I can see from my picture here that 1/3 is less than, it's smaller than 2/3. So I need to draw the less than sign. If you think about your alligator, the alligator is going to eat 2/3 because there is more food with 2/3 than there will be with 1/3. Moving on to this next question. Is 1/2 greater than, less than, or equal to 1/3? Now, the denominators are different, so that means you're going to have two different fractions that have different size pieces. So let's draw a picture again. Pictures are always very helpful with fractions. I'm going to draw a picture again. There's one rectangle. I'm going to partition it into halves, and we have 1/2 represented here. 1/2. And then I'm going to draw another rectangle that is the same size and partition it into thirds. I'm going to shade in 1/3. By looking at the pictures, we can see that 1/2 is greater than 1/3. And that makes sense because we know 1/2 is greater than 1/3 because we know that if the smaller the denominator or the bottom number, if the denominator is smaller, that means it has bigger pieces. The size of the pieces are bigger. So we know that 1/2, the pieces of 1/2, or of a shape partitioned into halves, is going to be bigger than a shape partitioned into thirds. So now you all need to practice more with these. Okay? Practice these. Draw pictures. Ask us for help if you need to. And then complete the page. Telling time. I'm going to draw minute and hour hands to show the time on each clock. So we know that the minute hand is the longer hand and the hour hand is the shorter hand. So I'm going to start with the hour since it's that's how we read it. So I need to go to the 2. So if we're telling time and the hour, if it's 2:53, 2:53 is what we're looking at here. 2:53. Right here, 2:53. And I need to draw a hand. If you're between 2, so 2:53, the hour hand is going to be between the 2 and the 3, If the time is closer to the next hour, which would be 3 o'clock, we draw that shorter hand closer to the 3. It's not exactly at the 3, but it's closer to the 3 because it's only 7 minutes from the 3. And now we need to go to 53. So I know that my minute hands count by 5 starting at the 1. So I'm going to label here 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55, and 60, or 0, wherever that's where the hour starts again. So if I need to go to 53, I'm going to find the 50, which is right here, and I'm going to count on 3 more. So I'm going to go 50, 51, 52, 53. So I need to draw my minute hand, which is the long hand, right towards there. I'm going to redo this to make it straighter. Okay, let's try again. 53. It's right there. So now my clock says 2:53. I'll model one more. I'm going to do 6:14 for you, and then you can practice the last 2 on your own. So we're going to do over here 6:14. Okay. So the hour hand is at the 6, and 14 is at the early stages of the hour. So we're pretty close to the 6 with our hour hand right now. So I'm going to go 6, hour hand, and then 14. So if I'm labeling, I'm going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50,